Hello students, in this video we will discuss some solutions based on topic turning effect of forces. The diagram shows a 3 meter uniform beam AB pivoted 1 meter from one end. The weight of the beam is 200 Newton. Copy the diagram and mark the beam center of mass. So center of mass is at the midpoint of the AB, since this is a symmetrical body, and the center of mass will work at the center of the symmetrical body. So this is from the one end, it is at since the length is 3 meters, so from one end it will be from 1.5 meter. Let's say this is 1.5 meter from the end A. The weight is acting here 200 Newton. Add arrow to show the following forces: the weight of the beam, this is the weight of the beam, and the contact force on the beam at the pivot end, this is the contact force at the pivot end. A third force F presses down on the beam at end A. Let's say this is force F. What value of F is needed to balance the beam? So we know that total clockwise movement is equal to total anti-clockwise if the beam is balanced. So F multiplied by the distance of F from the pivot is 1. So F multiplied by 1, which is the anti-clockwise movement, is equal to the clockwise movement. So clockwise movement is of weight. Movement is coming from the weight. So the clockwise movement is 200 Newton multiplied by the distance. Force multiplied by the perpendicular distance from the pivot, and the distance is, the total distance is 1.5, the weight is acting, and 1.5 minus 1 will be the zero point 0.5. This is 1.5 meter, and 1.5 minus 1 give you 0.5 meter distance. So 200 multiplied by 0.5, so force F is equal to 100 Newton. When this force is applied, what is the value of the contact force that the pivot exert on the beam? So contact force will be, total upward force will be equal to total downward force, F plus W, which is 100 Newton plus 200 Newton is equal to 300 Newton. Copy and complete the following statement. The moment of force about a point is, the moment of force about a point is force multiplied by perpendicular distance of force from the pivot. The diagram shows a uniform iron bar B of weight 30 Newton and length 1.4 meter. The whole length is 1.4 meter. The bar is being used to lift one edge of the concrete slab. This is a slab. A stone placed 0.20 meter from one end B act as a pivot. This is acting as a pivot. A force of 40 Newton pushing down at the other end of B. This is a force 40 Newton downward acting, is enough to lift the slab and hold it as shown. Copy the diagram and draw an arrow to show the weight of the bar B acting from its center of mass. So this is weight of the bar B acting at its center of mass. The whole length of the bar is 1.40 meter. So the center of mass will act at 0.7 meter. State the distance d of the center of mass from the pivot. So from the pivot it will be 0.5 meter, as this distance from center of mass to other end is 0.7 meter, and the distance is given here, this is 0.20 meter. The pivot is at one end, it is 0.20 meter. So this distance will be 0.5 meter. Calculate the total clockwise movement about the pivot of the force acting on bar B. So total clockwise movement is equal to force multiplied by distance, which is 30. This is a clockwise movement. 30 multiplied by 0.5, the distance from pivot is 0.5. Similarly, this force also contribute in clockwise motion 40, and the distance of this force from pivot is 1.2. This is 0.7 and this distance is 0.5. So 0.7 plus 0.5, 1.2. It means 40 multiplied by 1.2. So it is equal to 15 plus 48, which is 63 Newton meter. The system is balanced. The question is, Calculate the downward force which the slab S exert on the end of bar B. So the system is balanced. So total clockwise movement should be equal to total anti-clockwise movement. It means this is a total clockwise movement. The weight and the 40 Newton force was contributing in clockwise movement. The force F on the other end will contribute in anti-clockwise movement. So F multiplied by 0.20, its distance is 0.20, is equal to 63 Newton. F is equal to 63 divided by 0.2, which is 315 Newton. Suggest a change to the arrangement in the diagram that would reduce the force required to lift the slab. Increase the length of the slab, as the moment is force multiplied by distance r. So if you want to increase the moment, you have to increase the length. So the force required to lift the slab will be, the magnitude of the force will be reduced. Shows a mobile bird sculpture that has been created by an artist. M is the center of mass of the bird sculpture, including its tail. The center of mass is acting here, and the mass of the bird and tail is 1.5 kilogram. The bird sculpture is placed on a pivot. This is a pivot. The artist adds the counterweight at other end E. So the system is stationary. Calculate the mass of the counterweight. So mass of the bird and tail is 1.5 kg. Let's take the mass of the counterweight is small m. Clockwise movement is equal to anti-clockwise movement because the system is balanced. So mass force multiplied by distance. Movement is force multiplied by perpendicular distance. Force is mg multiplied by 12. The distance of center of mass from pivot is 12 centimeter, which is given. So it is equal. It should be equal to anti-clockwise movement. Anti-clockwise movement is small mg multiplied by 30. The distance is given 30. So 1.5, you cancel g from both sides, and 1.5 multiplied by 12 is equal to small m multiplied by 30. Small m is mass of counterweight acting at point E. So small m is equal to 18 divided by 30, which is 0.6 kilogram. So this is the mass of the counterweight. The center of mass of the sculpture with counterweight is at the pivot. Calculate the upward force acting at the pivot. So upward force is equal to total downward force. Upward force is equal to total downward mass into g. Force is mass multiplied by g, which is equal to total downward mass is 1.5 plus 0.6. 0.6 is the mass, is the counter weight at the pivot, and 1.5 kilogram is the mass of the bird and the tail. So 1.5 plus 0.6 multiplied by 9.88 should be equal to 20.58 Newton. If you take G as 10, which is approximate value, you can take 10 also. The sculpture is rotated clockwise to the position shown in the second diagram. It is held still, then carefully released. State whether the sculpture will stay in that position, rotate further clockwise, or rotate back anti-clockwise. So the sculpture will stay in that position. Explain your answer. The answer is, when you have changed, so the relative distance of the forces from the pivot are unchanged, as now the relative distance of the forces from pivot is px and py. The distance of force should be perpendicular from the pivot. We have to calculate the perpendicular distance. So earlier it was 12 and it was 30 centimeter. PE is 30 centimeter, and let's PM was 12 centimeter. Here, let's take this point P as pivot. So PM was 12 and PE was 30. Now in that position, PM and PE is not changed, but the perpendicular distance of forces will be Px and Py. So force multiplied by Px will be the moment. So Px is equal to, if this is a theta, this angle will be theta. Opposite angles are same. opposite vertical angles. And similarly, we can say that the px value will be 12 cos theta and py will be 30 cos theta. So clockwise movement will be 0.6 multiplied by 30 cos theta, and anti-clockwise movement will be 1.5 is the force multiplied by force is 1.5 g multiplied by 12 cos theta, and clockwise movement force is 0.6 g. 0.6 and 1.5 are mass m. Mass multiplied by g gives you the force weight, and these two numbers will be equal because cos theta in both case will have the same value, and 0.6 and 30 is equal to, if you multiply these number, gives you 80. Similarly, 1.5 multiplied by 12 gives you 18. Cos theta will be the same number on both sides, so clockwise movement will be equal to the same as the anti-clockwise movement in the disturbed position when you have disturbed. So the relative distance of the forces from pivot is unchanged, we can say, and the disturbance has not introduced any resulting torque on sculpture. This is a very important point to be understood, that why the resulting force, resulting torque has not been introduced in the sculpture, because the relative distance of the forces from the pivot is unchanged. So the sculpture will remain in its position. A meter rule balances when the 50 centimeter mark is directly above a pivot. State where in the rule its center of mass is located. Since the ruler is balanced, so the ruler center of mass is located at 50 centimeter mark. The center of mass of the apple is 25 centimeter from the pivot, and the center of mass of weight is 45 centimeter from pivot. Calculate the weight of the apple. So anti-clockwise movement is equal to clockwise movement. This system is balanced. Weight multiplied by distance, perpendicular distance 25 is equal to weight 0.4 multiplied by perpendicular distance 45. So W is equal to 18 divided by 25, it is 0.72 Newton. The mass of the apple, weight, the mass of the apple, W is equal to mg. M is the mass, weight divided by g is equal to 0.073 kilogram. The apple is not moved, the weight is removed from the rule and the pivot is moved to the left until the rule balances as shown in figure. Explain why the arrangement in figure balances. The arrangement will be balanced only if there is no resulting movement. It means that the movement due to the weight of the rule is equal and opposite to the movement due to weight of apple. In figure is closer to the 50 centimeter mark than to the center of mass of the apple. The pivot is closer to the 50 centimeter mark than to the center of mass to the apple. Compare the weight of the rule to the weight of the apple. So we know that if system is balanced, so anti-clockwise movement is equal to clockwise movement. Weight of apple multiplied by perpendicular distance of apple from pivot. This is the movement of apple is equal to weight of ruler multiplied by dr. Dr is the distance of ruler from the pivot. We know that dA is more than dr. So dr by dA will be less than 1. So WA divided by WR is equal to dr divided by dA. WA divided by WR should be less than 1 because dr by dA is less than 1. It means WA is less than WR. So weight of rule is more than the weight of apple. We can conclude. This figure shows a loaded wheelbarrow held in equilibrium by a gardener. The wheel of the wheelbarrow is in contact with the ground at point C. There are three vertical forces acting on the wheelbarrow. P is the upward force applied by the gardener. Q is the upward force of the ground on the wheel at the point C. W is the weight of the wheelbarrow and its contents. Explain why the force P is less than the force W by considering the forces P, Q and W. So total upward force is P plus Q and total downward force is W. W is equal to P plus Q and P is equal to W minus Q. You can think of like that. So P will always be less than W. By considering the moment of the forces P and W about point C, clockwise movement is equal to anti-clockwise movement. So P multiplied by dP is equal to, dP is the distance of P from the pivot, is equal to W multiplied by dW, distance of W from the pivot. So P divided by W is equal to dW divided by dP, which is less than 1. Since dW is less than dP, it means P is less than W. This figure shows a kitchen cupboard resting on a support and attached to a wall by a screw. The weight of the cupboard and its content is 75 Newton. G is the position of the center of mass of the cupboard. The clockwise and anti-clockwise movements about point P are equal. Calculate the force F exerted by the screw. So the clockwise movement is equal to, this is a 75 into 0.24. 75 and the distance, perpendicular distance 0.24. So this is 80. And anti-clockwise movement is equal to force multiplied by 0.75. The perpendicular distance is 0.75 of force. So F is equal to 18 divided by 0.75 is equal to 24 Newton. Perpendicular distance we are calculating from the support pivot. P is the pivot. So the perpendicular distance is 0.24. In this case, the distance of force from P is 0.75. This is important to understand how to calculate the distance of forces. This figure shows a uniform rectangular slab of concrete ABCD standing upright on the ground. The slab has height 0.60 meter, width and mass. A force of 40 Newton act horizontally to the left at B. Calculate the weight W of the concrete slab. So W is equal to M into G is equal to 18 into 10, 180 Newton. The thickness of the slab is given 0.040 meter. Calculate the pressure exerted by slab on the ground. Pressure is equal to force divided by area. Force is 180 Newton. Area is 0.40 multiplied by 0.30 is equal to 0.12. So pressure will be force divided by area 1500 Pascal. On this figure, draw the label and arrow to show the weight. This is a weight acting of the slab at its center of mass. Calculate the moment of the 40 Newton force about point D. D. So the distance of force from D and the perpendicular distance of force from D is 0.15 meter. And 40 Newton and the distance from D of 40 Newton is 0.60 meter. So movement of 40 Newton will be 40 multiplied by 0.60 Newton. Movement of W about D is W multiplied by the distance, perpendicular distance, so 0.15 multiplied by 180, which is 27 Newton meter. The ground is rough so that the slab does not slide. State and explain what happens to the slab as the horizontal force at B is gradually increased. When the force at B is gradually increased, the moment of force increases and becomes bigger than the moment of weight. The corner C lifts. You are increasing a force here. A corner C will lift from the ground, and in this case the center of gravity of the slab will be out of the baseline DC. So it brings the slab in unstable equilibrium and the slab topples. If the center of gravity, the line of center of gravity is out from the base of any object, the base is said to be in unstable equilibrium and it topples. So I suggest you to please watch where we have discussed detail the center of gravity and its discussion, how the center of gravity affects equilibrium. A large crane has a mass of 8500 kilogram. This figure shows the crane on a muddy building. So calculate the weight of the crane. Weight is mass multiplied by G. It is, you can take 10 value for G is approximation. The exact value of G is 9.8. So this is 85,000 Newton. The crane rests on two caterpillar tracks, each of which has a contact area with the ground is 3.4 meter square. Calculate the pressure that the crane exerts on the ground. So area of one caterpillar track is 3.4 meter square. Area of two will be 6.8 meter square. Pressure is equal to force divided by area. It is 1.25 into 10 to the power 4 Pascal. As the crane driver walks toward the crane, he starts to sink into the mud. He lays a wide plank of wood on the mud and then he walks along the plank. Explain why he does not sink into the mud when he walks along the plank. The area of wood plank is more than the area of driver's feet. So the pressure is reduced and driver walks easily along the plank. When the crane lifts a heavy load with its hook, the load exerts a movement on the lifting arm about the axle. Explain what is meant by moment of force. The turning effect of force is known as moment of force. It is the product of the force multiplied by the perpendicular distance from the line of action of the force to the pivot. Despite the movement exerted on the lifting arm, the crane remains in equilibrium. State the two conditions required for any object to be in equilibrium. So we know that the two conditions for any object to be equilibrium are the resultant force acting on the object must be zero and the total clockwise movement should be equal to total anti-clockwise movement. Write down the name of three man-made devices in everyday use that depend for their action upon the movement of forces. Scissors, wheelbarrow, and steering wheel. Shows a uniform rod AB acted upon by three equal forces F. State two reasons why the rod is not in equilibrium. Resultant force is not zero, as this force is cancelled out by this force, but there is one more force. Clockwise movement is not equal to anti-clockwise movement. So for equilibrium, two conditions should be there. The resultant force must be zero and total torque must be zero. This figure shows a uniform rod PQ supported at its center and held in a horizontal position. The length of PQ is 1 meter. A force of 12 Newton acts at a distance of 0.30 from the support, and a spring S fixed at its lower end is attached to the rod at Q. Calculate the force exerted on PQ by the spring. So the force 12 Newton, 0.30 is the distance from support, and this is anti-clockwise movement. Similarly, the spring introduced in the system clockwise movement, and the system is balanced in its position. So the clockwise movement will be equal to anti-clockwise movement. F multiplied by 0.5 is equal to 12 multiplied by 0.3 is equal to, so F is equal to 7.2 Newton. Explain why it is not necessary to know the weight of PQ. Weight acts at center of rod, pivot. The perpendicular distance of weight from the pivot is 0. Here the weight act here. So the movement due to weight is 0, hence it has no contribution in rotation of rod. So well students, thank you for watching this video, and please share, subscribe if you like video, and write your comments. Please write your feedback also so that we can improve and we can help you more. Thank you very much.